So warm-ups for today. That should look familiar. What does that look like? Good. That's the definition of a derivative. I'm not sure exactly what all is going on there, but that's the definition of a derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h. So yeah, that's the definition of a derivative. What is it taking the derivative of? Of cosine. Right? Because usually it's f of x plus h minus f of x all over h. So this is asking us to find, or this is the definition of the derivative of cosine. So this is where it's a little bit tricky, because we're actually not going to find a limit like we usually do. We're not going to plug in h equals 0, because we'd get 0 over 0, and there's nothing more we could do. So instead of actually evaluating the limit, we're going to recognize that that's the definition of the derivative of cosine. Well, what's the derivative of cosine? Negative sine. So what that really is negative sine of x. So f of x is the derivative of cosine. And again, whatever's right here is the f of x. So we take the derivative of that. Although I have to be careful because I labeled this f and then this f. So the derivative of cosine is f. So f is negative sine. You okay with how that's different than what we usually do with limits? Like usually we do some algebra stuff with limits. But this isn't doing tricks with limits. This is recognizing that this is the definition of a derivative. And then you know the derivative. So we really didn't do any limit thing. We just said, oh, that's the derivative of cosine, and the derivative of cosine is negative sine. So it's supposed to be I shouldn't say it's an easy question. It's not an easy question. There's not any computation to it. There's not any calculation to it. It's more concept recognition, definition recognition. All right, find the instantaneous rate of change of f. Instantaneous rate of change of f. That's fancy talk for what? Okay, find the slope or find the derivative. So we want f prime at pi over 4. So part B is, again, it's not really difficult. It's just, do you understand what's being asked? So f prime would be, what's the derivative of negative sine? Negative cosine, because the derivative of sine is cosine. The negative is kind of just along for the ride. So negative cosine of pi over 4. And that would actually be a safe stop, because cosine of pi over 4 is not a calculus problem. It's a pre-cal problem. I don't remember if this one is on the multiple choice or free response section, but if it's free response, you could be done. If it's multiple choice, we'd expect you to know what the cosine of pi over 4 is. Let's see, pi over 4 is right there. Cosine is the x-coordinate, so that would be root 2 over 2. But again, you could leave it like this if it's in the free response section. If it's in multiple choice, it's gonna look like this one. Emily?
So why did you derive the cosine from the top? If it wasn't, like, if it goes down to the f of x and it's not...
Yeah, I mean, it's a good question. So like, this, it probably didn't help that I labeled this f and this f. It might have been better if I called this G and this G. Of course, then I'd have to label all my... I don't know if that was the best choice or not. This, forget what we called it. This is the derivative of cosine.
Right.
The derivative of cosine is negative sine.
Okay.
So all of that, maybe it would have been better to just put it right there. All of that's equal to negative sine. Not because I know how to take limits, but because I just recognize that that's the definition of a derivative.
Okay, yeah. Okay, cool. Yes.
Okay, so there's a couple questions on the test like that where you're stuck thinking, I don't know how to do that limit. I don't remember the limit trick for that. Well, there's not a limit trick for that. It's just that's recognizing the definition of a derivative.
So then did you derive it twice? Then?
Well, this one, so this is negative sine of x.
Okay.
What we're calling f. Should have just left it as f.
Okay.
And then, so f is negative sine of x.
Okay.
But then I asked for the instantaneous rate of change of f.
Okay.
So that means the derivative of f. Well, forget that all we did up here.
Okay.
F's negative sine, instantaneous rate of change, is the derivative of negative sine.
Okay. Okay. Cool.
So yes, we did take two derivatives.
Okay.
One derivative because that's what this is, and the second derivative because it said instantaneous rate of change. Good questions. All right, I think number 2, just block off number 3, we'll go one at a time here. Number 2 is a little more straightforward. Find the tangent line to f at that point. It's a chain rule problem, so I'm going to hit pause and you guys try that one. So again, if we chain our 3 pieces together, the squared, the 2 comes down front, cosine to the first, cosine, derivative of cosine is negative sine, derivative of 6x 6, and then we should probably clean this up as best we can. It's going to be negative for sure. 3 times 2 times 6 is 36. So negative 36 cosine 6x sine of 6x. I mean, we're still a ways away from the answer, but there's our derivative. Maybe we should have started by thinking about tangent line means we need slope and a point. Well, the point it gave us, the slope is the derivative, and that's what we're working on right now. So I need the derivative at pi over 18, which seems like a terrible place to take a derivative because pi over 18 is not on the unit circle. But when we plug it in, cosine of 6 pi over 18, sine of 6 pi over 18. So both of those become pi over 3, which is a unit circle thing, so it worked out okay. Let's see, pi over 3. That's the steep angle in the first quadrant. So cosine is 1/2, and sine is root 3 over 2. And I guess conveniently enough, if you got those backwards, it wouldn't matter since they're being multiplied together. So that's kind of convenient there. Let's see. 36 divided by 4 is 9. So negative 9 root 3 is our slope. So I've got a slope. I've got a point. Now I can write now it's an algebra 1 question. Y minus 3/4 equals negative 9 root 3 x minus pi over 18.
If we were to leave the slope in like safe stop form, would this slope still be cancelled?
No, you could run out of space, but the question was, can we leave the slope in a safe stop form? Yes, you can. So as weird as it would have been to look at, you could write the line if you use this as the slope. So let's say you really didn't want to do anything with that. Like, I know it's a safe stop, I don't want to mess with it. Like, okay, that's the slope, so negative 36 cosine 6 pi over 18 sine of 6 pi over 18 times x minus pi over 18. That would be correct. I mean, as ugly as it is, it would still be correct. Just the main thing that people try to they get in trouble with trying to do that is they leave the x in there. If you leave the x in there, then you haven't told me what the slope is at that spot. So you've got to find the slope at the point, and then if you want to leave it in this ugly format, that is okay. You can do that. Certainly free response, that's definitely an okay answer. Multiple choice, it's probably going to look like that. Good question, though. So yeah, that's okay, because that's your safe stop slope, or your safe stop f prime at pi over 18. And so there's as we go on this year, there's plenty of times for you to leave ugly answers. And it's really fine, because when I'm working the key, like I'm going to have all the steps there, and I know where a safe stop is, and so if you stop there, that'll just be 2 or 3 stops short of where I take it to, but that's completely okay. I mean, I work it all the way out so that I can check the people who work it all the way out. Number 3, and final, for the warm-up anyway. It's kind of a unique problem. F of x is x cubed plus x minus e. It's unique because I didn't want to do a ton of warm-ups, but I wanted to cover as many things that were on the test as possible in warm-ups. So this provides a glimpse into like 3 or 4 different test questions. So f of x is x cubed plus x minus e. G of 1, so g, that's a different function. G of 1 is 7. G prime of 1 is 2. And I want you to find, let's just go one thing at a time here. Find the derivative of f of x times g of x at x equals 1. So what rule will we have to use? Product rule. All right, I'm going to hit pause and see if you can come up with an answer. I would write the product rule first with f and g, and then start plugging in pieces, because you can find f prime, and we just gave you g and g prime. So it's a little bit of a strange problem, because you'll have to take the derivative of f, but g, we gave you the derivatives. Anyway, you see how far you can take it. All right, there's a couple of hints, not hints, just first couple of steps. F prime, 3x squared plus 1. Again, e is a constant, so its derivative goes away. There's the product rule, fg prime plus gf prime. And then at 1, so we can start filling in the pieces. So maybe out to the side I come and write out what f of 1 is, what f prime of 1 is, and then now I've got all the pieces. Now it's just a matter of plugging them in the right spot. F of 1, 2 minus e. G prime of 1 is 2. G of 1, 7. And f prime of 1 is 4. And I would just leave it like that. I mean, yeah, you could distribute and multiply and collect like terms, but why bother?
Do you have to write it as 2 minus e, or could you leave it as 1 parentheses plus 1 without being a safe stop?
Yeah, you could have just left it as 1 plus 1 minus e,
Okay.
and then put that in right there. Yep. And I'm out of space, and I don't want to risk messing it up, so I'm just going to leave it like that. Like safe stop. If it's a free response question, use the safe stop. Otherwise, you risk, 9 out of 10 times, 90% of you would get this right, but that means 1/10 of you, 1/10 of the time, somewhere somebody's going to lose a couple points because they forget a negative or do 7 times 4 wrong or something silly that you'd get right most of the time, but don't risk it. If you can leave it, leave it. All right, I don't know that we've done this exactly yet, but it's not hard. with 2 marks there, you want to take a guess what that means? F prime prime. So how do you think you find F prime prime if you know F prime? Take the derivative again. So this is just an easy way to get you to practice more derivatives. So F prime prime. We start, it gets a little tedious to make little hash marks, so we start putting numbers up there. If it's a number in parentheses, that means the 3rd derivative, the 4th derivative, and so on. So these should be pretty quick and easy because we already have the 1st derivative. I just rewrote it there so we could. So find those real quick and then we'll go over those. And how about every derivative after that, for that matter? 0. So I don't know that we'd seen that notation before. So a 2nd derivative, a 3rd derivative, a 4th derivative, and so on. All right, test-inspired warm-ups. So definitely want to make note of those.